Hey everyone, and welcome. Today we are going to dive into the world of probability. We're going to break down the really simple but super powerful rules that are all about chance. Let's turn that confusion into clarity, shall we? Think about it. You're actually doing this stuff every single day without even realizing it. Choosing an outfit, figuring out if you need an umbrella, rolling a die in a board game. What are the odds, right? Well, it's not just guesswork. All of this, it's all run by the rules of probability. Okay, so before we can even get to the chance of something happening, we've got to take a step back. We first need to know all the different ways it could happen. So yeah, our journey here actually starts with something pretty basic, just counting. All right, let's get a couple of keywords down. First up is event. An event is just the thing we're interested in. So for example, rolling an odd number on a die. That's our event. Then we have cases. Cases are just the number of ways that event can actually happen. So if our event is rolling an odd number, the cases would be rolling a 1, a 3, or a 5. That gives us 3 different cases. Simple as that. And what's really cool is that almost all of this basic counting stuff boils down to just 2 little words, or and. Seriously, once you learn to spot these words, you know exactly what to do. If you see or, you're going to add. If you see and, you're going to multiply. That's the secret sauce right there. So let's kick things off with the or rule. Picture this. You've got a bag, and inside there are 2 yellow marbles and 5 blue marbles. Now, the question is, how many ways can you reach in and pick out a yellow marble or a blue one? Well, you can't pick both at the same time, right? It's one or the other. So you just add the possibilities. That's 2 ways to get a yellow plus 5 ways to get a blue, which means you have 7 total possibilities. Okay, so that's or, but what about when things happen together or at the same time? That's where our other keyword, and, comes into the picture. And this time, we're talking about the multiplication rule. Here's a classic example you've probably faced before. Let's say you've got 3 different t-shirts you like, and 2 pairs of pants that fit. To make an outfit, you need to pick a t-shirt and a pair of pants. So how many different outfits can you actually put together? The answer is 6. Now, why is it 6? Well, think about it. For each of those 3 t-shirts, you have 2 different options for pants. Since you're choosing a shirt and pants, you multiply the options. So 3 times 2. That gives you 6 unique outfits. See how that works? All right, so we've got the whole counting thing down. That's the foundation. Now it's time to build on that and turn those counts into what this is really all about, the actual chance or probability of something happening. And this right here, this is the big one. This is the core definition of probability. It's just a fraction. On top, you have the number of ways your desired outcome can happen. We call those favorable cases. And on the bottom, you have the total number of all possible outcomes. That's it. It's just a simple ratio of what you want versus everything that could happen. Okay, let's make this less abstract. Imagine we're playing a little game. I have 5 cards here, numbered 1, 2, 3, 4, and 5. I shuffle them up, and you pick one at random. What's the probability that you pick a card with an even number? Okay, let's break it down using our formula. First, what's the total number of things that could happen? Well, there are 5 cards, so there are 5 total cases. Easy enough? Now, what do we want to happen? We want an even number. Looking at our cards, 1, 2, 3, 4, 5, the only even ones are 2 and 4. So that's 2 favorable cases. The probability then is just 2 out of 5. Now, probability always lives on a scale from 0 to 1. That's its entire range. Let's start at the very bottom with 0. A probability of 0 isn't just, not very likely. It means it's absolutely 100% impossible. It cannot happen, period. And a perfect example of this is trying to roll a 7 on a standard 6-sided die. The sides are numbered 1 through 6. So how many ways can you roll a 7? 0 ways. There are no favorable cases. So the probability is 0 out of 6, which is just 0. It's impossible. Okay, so that's the impossible end of the scale. Let's flip to the other side, the number 1. A probability of 1 means it's a guaranteed thing. It's a total certainty. It's not just probably going to happen, it will happen. Let's go back to that die again. What's the probability of rolling a number that's 6 or less? Well, let's see. 1, 2, 3, 4, 5, and 6. All 6 possible outcomes fit that rule. So our number of favorable cases is 6, and the total number of cases is also 6. And what's 6 divided by 6? It's 1. It's a sure thing, guaranteed.
Okay, so we've got our counting rules, the whole and or thing, and we know that probability is just a fraction. Now it's time to put all of these pieces together into a really powerful little toolkit that'll help us solve all kinds of problems.
And this toolkit is basically made of three main tools. And guess what? They're going to look super familiar. We've got the OR rule, which is all about addition, the AND rule, which is all about multiplication, and then we've got this awesome little shortcut I like to call the NOT rule. So you see how our counting rules from earlier translate perfectly to probability? If you have an OR situation, you just add the probabilities of each thing. If you have an AND situation, you multiply them. Let's take that example. What's the probability of flipping a coin and getting tails and rolling a 2 on a die? Well, the probability of tails is 1/2. The probability of rolling a 2 is 1/6. So we just multiply them. 1/2 times 1/6 gives us 1/12. But, sometimes calculating the probability of the thing you actually want can get really complicated. Like, way too many possibilities to add up. When that happens, there's this fantastic shortcut. You just have to flip the question around and ask yourself, wait a minute, is it easier to figure out the probability of what I don't want? And that brings us to the NOT rule. The idea is simple. Since the probability of everything that could possibly happen adds up to 1, that's 100% certainty, remember? The chance of something not happening is just 1 minus the chance that it does happen. Think about it. If you have 20 products and 3 of them are bad, your chance of picking a bad one is 3 out of 20. So what's the chance of not picking a bad one? You just do 1 minus 320, which gets you 1720. It's such a great trick. So let's boil everything we've talked about down to a super simple cheat sheet. If you see the word OR, you add. If you see the word AND, you multiply. And if it's just easier to figure out the opposite of what you want, you just do 1 minus the probability of that event. That's it. At the end of the day, this stuff isn't just for a math test, right? These are the real rules that run the world of chance, from games and science to just your everyday decisions. So now you know the rules of the game. The only question is, how are you going to use them?